two parts in two holes separately, where the two holes are different in number. Then the logic states that the holes must also be multiplied with the.
But the logic must be based on some experience. That is the point. And now the second question. Do you think you have never seen this and you have never added it this way? You want to tell me this?
Huge numbers of students add.
Why? Everyone here have added it this way. Shall I tell you where? I will give you a chance. That addition appears in many documents. That's a hint. Huh? No. If denominator is 1 also, it will come out wrongly. Please be careful. You have never done it that way, you have never seen it. If it is a lie, I will take you all to the prison and lock you up there. So be careful in saying. You have never seen it, never added it. This is the beauty.
Correction.
Huh?
You correct papers and students beg for marks.
So you might not have noticed
Then
that.
you can do that.
Huh? Yeah,
You might not have noticed it.
you definitely have not noticed it. This is the usual thing. As soon as the second PUC exams are out, all get huge marks. Okay, let's say very good in mathematics, they have 100 out of 100. How do you add this? Huh? How do you add this? By my rule or by what are you doing there? Huh? And all of you claim you have never seen that. You want to still claim that? In marks cards you add like that. No, that's what. That was the point of disagreement. Denominator also said. Tell me. And I started off by saying I don't want to insult your intelligence, but now. Are you challenged? Now tell me. Thing which you have been doing and now I say this is not proper. And sometimes you add this way and sometimes you know how much is this actually? Huh? I have not seen it added any differently anywhere. Now how do you explain to me when half plus half is this? Huh? I can make it anything you want. No, 1 by half plus 3 by 4 is 1.
Now you got the right answer.
So that is the average that we are speaking. This is the average, but sum is different from the average.
Average is against sum.
Yes, but
The definition of average is average.
yes, average is sum, but on that sum we divide with another number.
This answer is
We
right.
divide that sum with another number when you put it as.
Why?
3 plus 1, 4 by 2 is 2.
No.
Half plus 1
You have to add this also.
Yeah.
To be 4 by 4,
4 by 4.
which is 1. Yeah, now you know why I got a PhD. Huh? I can confuse people with very simple things which they know. And now if I ask you, do you give me a doctorate, they'll have to say, yes sir, please, leave us alone and let's get on. And this is wrong because we use a very popular model. That's what I said, you confuse a model with the actual thing. And that is the most troublesome thing in the world. The point is, the thing which is used to give idea of fractions is universally apple. I don't know why apple, but supposed to be somehow. So I thought it was only in India, but a French mathematician also writes saying that I don't know why this apple has become an example. So everywhere it's apple. So we say you take an apple, cut it into two, take one half. That is called half an apple. Okay, I take one apple, cut it into half, take one half. Then I take another apple, cut it into two, take another half. So now if you ask me, addition means what? Putting things together. I put. So what do I have? have 2 half pieces out of 4 half pieces, which is 2 by 4. You did not get 1. So the thing that half plus half an apple plus half an apple is 1 half is wrong. It is, the thing is the unexplainable, unexplained thing, there is addition. What do you mean by adding is the question. And that cannot be. Adding does not mean, well, if you have tried it with young children, you would know. They want a full apple, you take it, cut it into pieces and give because you think it's easier for them to consume. They say, no, I want the full apple. And if you have another, it's good. If you didn't have another apple, you would be in a problem. If you know the famous story of Birbal and Akbar, where Birbal said, no, bring the sugar cane, cut it, this, and they said, no, I want the pole again. So you can't. So addition is not putting things, so routinely we keep saying addition means putting things together, putting things together. Sometimes you can't put things together. If you take one chair and then bring another chair, it is 2 chairs. You can't do anything with it. You can't say I will bring half a chair and put it together. It won't become 1 chair. So that's the problem. The problem with mathematics is, unlike many other, physics or chemistry, there is nothing to show. Things have to happen in the head. And that happening cannot be accelerated. That's what we mean when I was saying that you can take a horse to the pond, but you can't make it drink. I can give lots of examples. I'll come to why this is. So this rule for adding fractions is a fairly complex thing, you would agree, unlike the thing. And just at this point itself, to give you a very stark contrast, I will give you something else. I hope today you will go home and realize how many wrong things you have been doing. Look at the case of complex numbers. A plus IB plus C plus ID. What is that? Add the real parts and you add the imaginary parts. And then I multiply. This is exactly the other way around. There you did multiplication straightforward, but for addition you had a complicated rule. And here, addition you do straightforward, multiplication you have a complicated. No matter people find mathematics difficult. You are not consistent. You don't do things nicely. And then you go to matrices, and matrices is even more haphazard. You don't even multiply 2 matrices of the same order. I can't take 2 by 3 matrices and multiply them. I can add them. So you thought you do a lot of mathematics, elementary, etc., etc. That's why teachers find it difficult to teach primary students. Because the primary students, they have no idea. You say half an apple plus half an apple is 1 apple, and that idea does not get into their heads. It has not got into our heads also. What we do is we learn it from somewhere and we tell it, that's all. That's why he says education should become an experience. You should experience, then only you can communicate. Otherwise you will just hear from this side, say it from the mouth and be done with it. It does not become knowledge. Okay? The main thing I want to stress out is, here is, nothing is explainable as it is. So as I said, if I write this rule and you say it's wrong, whether it's right or wrong depends on the context. What meaning you are giving for A by B, C by D, etc. See, your brother might be writing a program to prepare a marks card. And then he might say, what algorithm should I put for adding marks? And he will say, yeah, take the denominator, LCM, etc., etc. He will come up with the wrong answer. So the teacher will say the program is wrong. So there the formula I have to write is precisely this. All your marks card generating have this as the formula. So if you look at it, you might. Okay? So now I will give you a quotation of Bertrand Russell. It's a very beautiful quotation. If I had given it any preface, there would have been roaring laughter in the class, but now I will give you. And sympathy for all mathematicians. But now if I gave, I think you will understand the statement in honest. He says, mathematics is a subject in which the person doing it does not know what he or she is doing. And even more dramatically, they don't even care whether what they do is right or wrong. So it's a free for all subject. It was difficult when Bertrand Russell gave this statement. It required a lot of thinking to understand this. Today it is very easy. Does a computer realize what it is doing? Whether you are booking a ticket for a train, or whether you are playing a MP3 file, or you are manipulating an image, or performing some complex calculation. Computer does not know. And it does not even care whether it is right or wrong. You wanted to book a ticket to Bombay on 17, but you booked to Delhi on 15. It gives you. Why does it care whether its answer is right or wrong? It does it as you have told it. That's the point about that. By itself, it has no. So that's the reason. The attitude towards mathematics has to change. It's not like it's part of science or something which is an experimental observation, etc. It's more like a language. So that's what I meant in my talk. Mathematics is the language of science and technology. And it's like a language, you have to use it by learning it. How many of you have learned a language from studying the dictionaries? We don't. We don't learn the language from dictionaries. I mean, I'm sure there are people who have never looked at a dictionary. Right? So if it was learning from a dictionary, because dictionary. So the way we are learning mathematics is by learning a language using the dictionary. What is a matrix? A rectangular array of numbers. So what? It does not tell you how to add matrices. When you say add matrices, what should you do? You put them together. If you put together, you get two matrices. I mean, that's all. So it depends on the context. So, for example, if somebody, so that's why I say, if somebody asks you A by B plus C by D is equal to what, Bhaiya or Didi, don't immediately give the answer. Ask them what they are actually adding, marks or fractions. Because the subtle thing is, the same symbol A by D is used for two different things. One, as an independent number and as a part of a whole. These are certainly two different concepts. Part of a whole, I can give a model and explain. As a number itself, I can't explain. Half as a number, independent number. Half an apple does not exist without one full apple. But half a kg of sugar has independent existence. I can measure half a kg of sugar without having 1 kg of sugar. So there half is again this is an approximation. And we understand. Half is a number which we have to just realize. Yeah, that tells you 2, for example, it's impossible to define what 2 is. So usually people say computers don't understand language, they understand numbers. And let me tell you, they don't understand numbers either. Because we don't understand what. How do we know what is 2? We associate it with the objects. We say 2 dogs, 2 chocolates, 2 chairs, 2 people. And finally that idea of 2 sticks in the mind. And if we now show cows and ask how many are there, they will see, okay, 2. Or not 2. So, yeah, this is purely human. It can never be transmitted to a machine. So what the computer is doing is actually a very elaborate drama. It is like, I want to enact Ramayana today. So one nice thing actually would be to invite Rama, Sita, Lakshmana all to come and give a performance. Day out of their life. Live in front of us on the stage. But unfortunately, we don't even know whether they existed, whether they exist, etc., etc. So we try to make approximation. This guy acts very well. Let him play Rama and somebody else Sita. And for the duration of the play, they are Rama and Sita. And all of you know, and I also know, they are not actually Rama and Sita, but something else. Similarly here, what the computer is doing is actually an extremely elaborate drama, which is a tribute to the human mind. The director of the play, so to speak, he has found out all small niceties and put them together. He has not chosen a very young actor for Rama and a fairly old lady for Sita. He maintained that they should look like husband and wife, not like son and mother. This kind of stuff. Otherwise, what a director I say. She may be acting well, but he may be acting well, but they don't fit there. Rama and Sita are supposed to be husband and wife. Whereas this one is extremely, who plays the role of what? All of you know. There's a physical thing which plays the role of 1, 0 and a physical. It is the state of a. These two are the famous actors. Off as 0 and on as 1. And using just these two actors, an elaborate script, we do all our. And that's the beauty of it. Everything is related to it. Whether you want to record a song, capture an image, reserve a ticket, do a elaborate computation, finally 0, you have switch on some lights, switch off some lights, which is done by the ICs and yet, incidentally, there are 13 levels in a computer. From the user interface to the absolute logic gates. So when you say something here at the command interface, it seeps down. That language, then a higher level language, then it gets compiled into a machine language, and that machine language is something. Finally, it's opening and closing of gates. So a single command might result in actually billion opening and closing of gates at that end. And that's the, as I said, tribute to. And that's where I am always worried. A few electrons decide to go in a different way than intended. And all accidents happen there. Okay? So that's the point about it. Just a symbol as it stands does not mean anything. So A by B, we don't know whether it's half a kg of sugar or A marks out of a total of B in a quiz. So depending on that, you have to. So like the comparison to language is very simple. If somebody what is the meaning of root? Do we ever say the answer? We first ask what is the spelling. You might be asking root, R-O-U-T-E, root, what is the root of this bus, and you might be saying, your preference is biology, you might be saying, you know, it is in the plant, it is that thing which grows below the ground, etc. Then they will say, what is this? Bus root has got to do with the plant. So we'll ask first the spelling, and even if the spelling it's not clear. Again, it is R-O-O-T root, you might be reading a mathematics. And you say root of 4 is equal to 2, they would have written, and you say, what is the meaning of root? And again, it is a plant, connecting 4 root and 2, etc., and this plant would be. Similarly here, what is A by B? Mathematician's answer should be, well, what do you want it to be? I am a license granting authority. I can tell you whether you can do it that way or not. Okay, and that's it. And you can say, okay, I understand fractions. What is the sum of two fractions? Again, if you think mathematician will give out an answer, no. You again say, okay, what do you want it to be? Then they will say. The example is, for example, vectors. Physicists will come to mathematicians and say, what is the addition of two vectors? What do you want it to be? You see vectors, forces. Forces are vectors. So I am applying one force in this direction, another force, and I want to know what is the resultant. Therefore, I am putting two forces together, and I want to know what is the resulting force. So I am representing them by vectors, and I want to know what is the addition. So applying this two forces on the same object, I want to look at it as addition of the respective vector forces. Then if you think the mathematician will give out the answer, you are again wrong. You will say, okay, go to your lab and do some experiments and come up with a table. So he will have to again go back, take various forces. I applied force 1, force 2, there is an object moving in this direction. Another set of force, the object moving this direction. He prepares a table and brings it. And then the mathematician's job starts there. Then they say, okay, I will analyze this table and give you a formula which will fit all the, right? Similarly, then what comes up is vector addition. Otherwise, if you say two vectors, I have two vectors, if I put them together, what happens? Do you realize there is another meaning for vector? A totally different context. Biology. Vectors are carriers of disease. So there, vector addition does not mean anything. If you had 100 vectors in one city and if you brought 100 vectors from another city, you would have 200 vectors. Mosquitoes, for example. So it very much depends on the context. Like Alice in Wonderland, well, you can make the world whatever you want it to mean, only you have to pay them more. Okay? So please beware when these formulas are like that, by themselves they don't have any meaning. Like a dictionary, we supply meaning, but unlike we learn a language, we cannot learn mathematics by mugging up formulas like this, which is why we are not able to learn mathematics properly and appreciate it. And that's why I tell you there is nothing called applied mathematics. Does anyone study applied Kannada? Kannada, pure Kannada is what is defined in the dictionary. And applied Kannada is what is poetry or even maybe your job application form or your CV. Like Kannada is mathematics. It is a language and you have to see it. So I would actually like in a mathematics question paper to ask questions like this. Give me a context in which this formula is true. Where I want you to give meaning for A by B, meaning for A, B, C, D themselves. They could be any damn thing. A, B, C, D themselves can be matrices. And by dividing two matrices, I might mean take this matrix, take the inverse of this matrix, multiply them together, etc. For image manipulation, that might. So I might say, give me a context in which A plus B plus C by D is equal to A plus C by D plus C. Or explain in which context this is true or this is wrong. I would ask questions like that in a mathematics question. Okay. So it's the language. And like a language, the stress is on there's an object and there's a meaning. And the meaning and the object, they go together. You remove it, it does not make sense anymore. I said this formula is also correct. The other formula you mentioned, which is BD in the denominator and AD plus BC in the numerator, is also correct. Depends on the context. Okay? That's the reason why mathematics education has become very irrelevant. I have seen mathematics for engineering college. So I was in the Tata Institute of Fundamental Research actually, in IISc campus, but till 2005 they went to engineering college. There was a sea change. So there is mathematics course going on, Fourier series, Fourier integrals, etc. And electronic students are studying signals and systems without realizing that they are studying the same object. So for electronics engineers and all, Fourier series is a 4 or 5 term finite series, where for mathematicians it's an infinite series which is useful in many different understanding mathematics, etc. So unless you build that connection, we can't make good engineers, good mathematics. And all the mathematics, without any trace of doubt, has developed out of necessity. Like a language. Language develops out of necessity. And after the necessity things are developed, then you have poetry. First function of a language is communication. I have something to say to you and I should have a way of doing that. And after that we have developed lots of vocabulary, etc., etc. Then you have leisure and poetry and other things come out of it. But that is not the original. Similarly mathematics. And many times it pays back like this. So they had numbers for use for denoting things, cattle, etc., etc. And then various other kinds of numbers came in, that was, and addition. And as and when it develops, you have to give meanings to it and use it in different contexts. And at the end, there was a very famous debate in 80s, mid-80s. In America, what happened was there is this National Science Foundation, like what we have here. There is a professional body of scientists which honor a given scientist by making him a fellow, electing a person as a fellow. So National Science Academy in US, very prestigious body. And they nominated one Huntington, a very famous economist, to the National Science Academy. Then, of course, people who elect them have to see what this guy has done and then whether to support him or not. So there was a group of mathematicians who were a bit worried about this fellow, because this Huntington, you can check the record, what are Huntington's laws in economics. So he had done, if P denotes population, if G denotes the GDP of a country, etc., etc., and he had some algebraic, like Maxwell's equations, he had a set of equations which were called Huntington's laws. Now, this was challenged by mathematicians. So they said, what he has written there is total nonsense as far as mathematics is concerned. He has used the language of mathematics. There are laws, there are notations, there are quantities put together in a certain way, and there are equations written, like E is equal to MC squared. Then, what is it? So then there was a mathematician by Neil Koblitz who examined it in great detail. So he, for example, took a couple of his laws and said, okay, I have this equation, I have this equation. Now, I manipulate according to given laws of mathematics. And he has given the all the permission. And then he arrived at some fantastic result. I mean, see, population, P denoting population makes sense. But what would 1 over P mean then? 1 over P would not have any meaning. 1 over population does not make sense. So he said, you have to be very careful when you use, mathematics is a language, you are using it wrongly. Like for example, somebody who may not know English properly might translate things wrong. When you say you are using it wrongly. Very famous example is about the program stands. That's actually ambiguous, whether it stands cancelled or it stands as it is. So apparently that's what happened. The minister was to visit a town, and then they said we will confirm it at the end. So then the people were all waiting, and they got a telegram, the program stands. So the village panchayat did not understand it. He gave telegram to the most educated person in the village and said, what does it mean? He looked at the program. Karyakrama stands into there. Panchayat that program is cancelled because it didn't go with the Karyakrama. So they all went home, and a few minutes later the minister drove into the village. And of course, a lot of people were suspended, memos were issued, etc. Wrong interpretation. So Koblitz claimed Huntington's laws violate mathematics. If he is formulating them in the language of mathematics, because using symbols of mathematics. He is using multiplication symbol, he is using addition symbol, he is using equality. You have to be careful. So then it was the law, and they stalled his election twice in succession. Twice. Neil Koblitz and others are very, these are people who are very publicly active. They were good mathematicians, but they were also publicly. See, this is what Professor Balram meant by saying you have to be in touch with the society. You can't be away from it. And on the side of Huntington were very famous people, one by Herbert Simon, who is a Nobel Prize winning economist. So he was on the side of Huntington. So it was a battle with stalwarts on either side. So for every rejoinder of Koblitz, Huntington would say yes. But like 1 over 0, you don't give a meaning, you don't give a meaning for 1 over P. You can actually make. So it was a very informed debate, it raged for a long time. Finally, their ground was sort of weak because he was lost. They had not completely specified everything. So finally, Neil Koblitz, there was a lot of exchange, and the editor decided that the debate should stop. That's when Neil Koblitz's final letter he wrote, yes, like Alice in Wonderland, you can say, I can make the words mean what I want to. Only I have to pay them more. So that's the point. So mathematics is a language. You have to learn it in a context. Okay. So then to sort of give you a nice, then what would you mean by a small poem in mathematics? So let me give you an example. So this will actually take you to think what do you mean by a poem? Design this, that, etc. My poem, I would say this, it is something, when you look at it, you feel nice, happy, and then will remember. That is the beauty of a poem. Your same prose text in a para, you might not stick in your head, but because put in various contexts. So one of my favorites, I would say, it's called not anything great by each sentence. Like most poetry, the first line is not deep. One more line. For me, this is a poem in mathematics. True, every line. And what is the nice thing about it? It is a beautiful pattern. And I tell you, you make posters of this and display it as works of art in your house or in the school, and tell you the point about that. I am quite sure this has happened everywhere. Even people who are not part of the audience have actually done the addition. And that's the point. So for example, you might be sitting in the waiting room of a doctor, and if this is there, your brain will not, you can't help it from actually carrying out. So 1 plus 2 is 3 straightforward, then you become slightly curious, then you say, okay, 4 plus 5, then you add it intelligently, 4 plus 6 is 10, plus 5 is 3, 7 plus 8 is 5. And then now you become more curious, then you say 9 plus 10, then things start getting a little difficult. By the time they actually verify this, either their disease will be cured and they will go home, or the doctor will call them inside. And that's what I meant. This is where you make a person do a thing without actually asking them to do. And that's actually the time you convey it the best. You don't make addition as the main focus of the class. You make addition as a way to something. You ask students whether check whether this is right or not. And you don't even have to tell them. Don't even have to tell. And lot of mathematics is hidden in the I'm sure all of you will remember this table, this equation, and that's why I call it a small poem. So I told you mathematics is a language and I have to justify my statements. And to give you a poem in which only symbols appear, this is one side. And sometimes the meaning is hidden. In this case, it's very obvious, right? And it continues, and I can ask you lots of important, interesting questions. For example, what would be the first number on the 10th line? I call it first line, second line, third line, fourth line. What would be the first number? 100. And how many will be on the left hand side, right hand side? So I can make it a very interesting activity for the entire class, even at second standard, third standard. And mind you, I can take it to even high school levels by asking what is the sum of these particular 2 plus 6 plus 12 plus 20, what is the next number, and generate what is the sum on either side. Yeah, and without stretching too much, I might teach you quite an amount of mathematics. So this is one poem where the meaning is obvious. And there are many, of course, where the meaning is not obvious, and in some sense, it's my duty to my friend, Mr. Srinivasan, who was an elderly colleague in PIFR, who was a number theorist. He had done lots of interesting work in number theory. But he was very fond of one thing he discovered, which he always shares. He said, yoga, I want more and more people to see this. So whenever you talk to people, you show them. He said he just saw this. There's something very beautiful there. Does anyone realize? Okay, let me cut out some small things because of lack of time. There is a regularity, there is a pattern, there is a difference of 4 between every two, etc. All good. Do you see anything else?
Diagonals. Diagonals are.
Comes up to me.
Yeah, that's why he was very right in saying that he does not know anyone who has actually seen that pattern. Shall I? And now all of you will see the second also. That's the hidden thing. That's the beauty of a poet. Unless the poet explains what he is intending, you don't know. Which is why you require bhashyas and other things. So I hope I have justified the role of mathematics as a language in all these things. Now I'm coming to my this thing. So let me say a few more things, general other things. So one was this, Professor Balram mentioned Einstein's theory of relativity as an invention, like another thing like light bulb, and said maybe not so useful invention. But I want to tell you that general theory of relativity, which came out after special theory of relativity, is part of our daily lives now. We have to be grateful for general theory of relativity for something which we carry in our pockets now. What is it? Yeah, do you know where its role is? General theory of relativity.
Satellites.
Huh?
Generally, all matter is related to outer space.
Correction of time. To give you the actual figure, if that general theory of relativity correction is not applied to time, determination of mobile, your clock, mobile clock will not run accurately for more than 15 minutes. That's all. That is the power. If general theory of relativity had not been developed, your mobile phones would not have been possible. Full stop. Because who would carry something which would not show accurate time for more than 15 minutes? See, if it made in 1 month or 1 year, it goes correctly, people will make correction. So say, okay, we can live with it. Every now, recently it was announced, the world over, we have slowed down by a second or something like that we can. But here it is a matter of bread and butter. If your clock cannot run accurately for more than 15 minutes, you better not use that clock. So general theory of relativity does have its use. So you might think it is the most exotic outcome of the human mind. But again, the same human mind will find someday a thing which can be used. Use is again an inverted comma. So you should have the patience and the necessary conviction to learn further. And as far as the education is concerned, the main problem everywhere is actually put very simply. The whole point of education is to show cause-effect relationship. All science, everything is taught to you only to finally show there is something. This is called the principle of causality, that every cause should have an effect and every effect should have a cause. And the whole aim of all human endeavors is to find this relationship. Okay? So that is it. So if you give this much current, what would be the speed it would be running? If you give this much acceleration, what is it? So you have to find the relationship, and all quest is directed towards it. Okay? I will explain it in, that is exactly why this formula became very famous. Yeah, I wrote it in the wrong way so that so always used to E is equal to MC square, which is the same thing. But the point of this thing is, if you ask me frankly, nobody except theoreticians have certified its correctness. You cannot say I did this experiment and it verifies this law. That is not done. They might say, no, if I use this, if I take the mass of the proton and the value into energy, etc., then that is not indirect evidence. Nobody says I take 1 kg of matter, convert it completely into energy, I am getting this much, therefore this equation is true. So a lot of nuclear energy requires a lot of funding, right? It requires enormous funding to do. And why did people find it very interesting to invest on it? Can anyone tell me? Why did people think this E is equal to mc? See, people usually mistake by saying Einstein discovered that mass can be converted into energy. That is not true. We all knew. We all eat and do work. And that is mass to energy conversion. There is no doubt about that. Burn a candle, get light. So mass to energy conversion is happening, we all knew. Einstein found there are many formulas, how much kinetic energy depending on mass, etc. And etc. Einstein found a new formula and he said, okay, if I get pure mass as energy. So why did it become so important? The reason is because of this factor. If it was something like m divided m root c is equal to E, I am not sure whether it would have really become as, or even m c in the denominator, nobody would have even rooted it second time. Point is, c is a fairly large number, velocity of light. So they were, small mass you take and convert it into energy, you will get enormous amount of energy was the realization. So then people said, then this is worth pursuing. What you do is worth pursuing. See, if I say, if you do 2 kilometers here, and I assure you there is 10 grams of gold, I am not sure people will really think this. First of all, school will not give you permission. But I come to you with infallible proof. There is a 2 tons of gold if you go 5 kilometers. 5 is too much. 1 kilometer is enough. Because even Kolar gold mines is not there. So if you dig nearly 1 kilometer, madam, you will get 2 tons of gold. Here is the proof. I give you that. And the school will say, good. Let's invest 5 crores, buy land there and shift the school there. This we will dig. And that's the point. They said, if you invest, you are assured of fairly large income. Then you invest. And that's the funding. So what you have to do is to convince the government or the funding agent that if you do this, returns are very high. Then you will get it. Okay? So that was the thing. And then I have one final thing to say about pushing people or dragging into science. Because I have done both. And actually it did not require any force. That's the beauty of it all. And about the question as to whether parents should have a say in the science children's education or children should have their final say, I have no doubt about that. I talk to our parents and tell them, see, my life, for example, is another 20 years. Whereas my son has to live for another 60 years. So it is his world, his life, and he has a better say. Because after 20 years, I go. I am not there for him to blame or praise or anything like that. So we all have to realize that. We all have to make way. It is there. And if they make mistakes, yes, who does not? And we have no idea. And they being in their area, they are more comfortable. They have, in fact, they are not actually taking very rash decisions. We say you are taking a rash decision, but it is rash as far as we are concerned. They want to. So, especially most of you are in the final years or just finished anything, etc. I would suggest that you take some time settling down, in finding, because you have to live another 40 years after that in your career. So if you spend a few years now, it does not matter. Whereas joining an engineering college after PUC, your effort should be limited, because the duration is only 4 years. You just suffer it out. If you don't get it out in a good place, you just suffer it out. But don't apply the same principle for the job. But unfortunately, we are doing the reverse. College, we are extremely particular. It does not matter if person is demanding 25 lakhs, but I want my son to have the best education. Let me job. For a job, they say, I'm offering you, why don't you go and join? Why don't you go and join? And they push them into a software startup which will close after 4 years. So, you do the reverse. While choosing a college, be a bit compromising. Okay, Bagalkot, let me go and stay there and be done with it for 4 years. Whereas taking a job, think about it. It takes time. It's a famous song in Sound of Music, I don't know whether I've seen it. They say how to find your aim in life. Climb every mountain, follow every byway. Climb and follow every byway. Look high and low, follow your dream. A dream which will need all the love you can give every day of your life, as long as you live. So to find such a thing, you need to spend some time. Do that. All the best.